the digital cellular networks, there's an entity, a base station, an access point to which the end device is transmitting data and receiving data from. Well, the first broad class of wireless networks are known as Wi-Fi or wireless LAN, WLAN networks. We've already seen these in the context of home networks, but they're also widely deployed within municipalities, with companies and other institutions as well. They tend to operate in the range of about 10 to 100 meters, if you're lucky at 100 meters, and they operate at different speeds from 11 to 54 to 450 megabits per second. These protocols are actually standardized by the IEEE under the family of 802.11 protocols. They're not standardized by the IETF. The second broad class of networks are the 3G, 4G, and soon 5G cellular networks. These networks are operated by the mobile cellular operators, and they tend to have a transmission distance measured in the tens of kilometers, and they can have transmission rates anywhere from 1 to 10 to multiple tens of megabits per second per user. And finally, there are enterprise networks. And we might think of some enterprise networks sort of like home networks on steroids. An enterprise network could have a mix of Ethernet, wired Ethernet, and wireless Wi-Fi links. And one difference from a home network is that an enterprise network would typically have multiple switches and routers to handle a large number of devices that would be connected to that enterprise network. Another type of enterprise network that doesn't look at all like a home network are data center networks that connect massive numbers of servers to each other and to the internet at hundreds of gigabits per second. We'll cover data center networks in detail in Chapter 6. Well, that's all we're going to say for now about access networks, and we're going to come back to this in great detail when we get to Chapters 6 and 7. For now, you might want to just think about the physical media that we've been talking about, the copper wires, the fiber optics, and the radio links, and we're going to get to that in just a second. But first, I want to say a few words about packets. I've used the phrase packets of data, and we've talked about how a sender sends a packet of data into the access network. What does that really mean? Let's take a look at this host here, which is sending data to a first hop switch here, and consider it sending operation. The highest level, the host has some data it wants to send, say a large file. What does the host do? Well, the host is going to take the data it wants to send and break it into smaller chunks of data known as packets. And as we'll see, in addition to the data itself, it'll add some additional information to each chunk of data in what's called a packet header. A protocol will dictate exactly what information is added into this header. A packet, the data plus the header, will have a length of, say, L bits. Typical value for L might be 1500 bytes. The host then transmits this L-bit packet into the access network at some transmission rate R, measured in bits per second. And as we've already seen, R varies from one type of access network to another. We saw that using wired Ethernet, a host can send at gigabits per second. But over a 3G or 4G network, it may be constrained to a few megabits per second or less. R is best thought of as a link transmission rate, but it's sometimes more informally referred to as the link capacity or the link bandwidth. If one wants to send an L-bit packet into a link at transmission rate R, then the amount of time it takes to send those bits into the link is the number of bits to send, L, divided by the transmission rate, R. And we'll come back to this later. Well, we're going to wrap up here by taking a quick look at the physical characteristics of different transmission media. But before doing so, I wanted to say just a quick word about our depth of coverage here. There are tons of interesting topics that we could cover here in terms of modulation, encoding, and things that have to do with the physical transmission of bits. But there's only so much that we can fit into a course. And so here, we're going to go over this pretty...
Because watching Google, they have to ask you to log in for Google now. That's only recently, right? I don't know. Anyway, keep that. See. Maybe next time I will log in.
Pretty lightly, if that's the kind of thing that gets you really excited, you want to learn more, you should definitely take another course and you should pick up another book on this. We're going to be looking at the physical characteristics of different transmission media at a rather high level. We're going to be concerned about what are the bit loss characteristics, how do signals interfere, what do propagation delays look like, but we won't get down into the details of how different physical transmission media work. If you want to do that, pick up some more material. You know, it's really a question of taste, and this is a course on networking. We're going to start from here and work our way up. Okay, so here are some very basic facts about physical media. Remember, what we want to do is send digital bits over some physical media from sender to receiver. The physical media could be what's called guided media. That's some kind of physical wire or cable, maybe made of copper or optical fiber. Or it could be over unguided media, where signals propagate freely, like radio or acoustical waves. Twisted pair used to refer to the real twisted pair of wires that carried your grandparents' telephone signals into the house, but now refers also to Ethernet or ADSL and runs at hundreds of megabits per second and sometimes gigabits per second. They can be susceptible to electromagnetic noise. You've probably seen Ethernet cables like this in your home or office or school. Coaxial cables used to carry cable network access into your home and operates at hundreds of megabits per second. Old-fashioned Ethernet actually used to run over cables like this, but not for at least 20 years. Fiber optics cable carry light pulses and operate at hundreds of gigabits per second and higher and have very low error rates. So in some sense, they're really ideal for communication, but the transmitting and receiving components tend to be more expensive than that for traditional copper wires. With a wireless link, bits are modulated onto a signal carried in some frequency band in the electromagnetic spectrum. There's no physical wire, and transmissions tend to be broadcast, meaning that any device near the transmitting device may be able to receive the transmitted signals. And this obviously raises eavesdropping and also interference concerns. Wireless is a notoriously harsh environment for transmitting. Radio signals fade over distance. Depending on the frequency, signals can be reflected off of objects or blocked by objects, or at other frequencies, they can just pass right through objects like walls. They're subject to noise generated by motors, microwaves, and other devices that emit RF signal. So transmitting bits over wireless requires a lot of work at the physical layer, and that's why there are entire courses devoted to this topic. There are many types of wireless links that you're probably familiar with. We've already discussed Wi-Fi networks that can transmit at up to hundreds of megabits per second, maybe over tens of meters distances. 4G cellular networks transmit data at rates of tens of megabits per second over distances of up to, say, 10 miles. Many of you probably use Bluetooth, which is used as a cable replacement technology and operates at relatively low data rates, say 1 or 2 megabits per second max, and over a relatively short range, usually not more than 5 or 10 meters. And here are other forms of wireless networks. There's terrestrial microwave that operates at tens of megabits per second, point to point, and that's about the same transmission rate for satellites. In the case of satellites, there's a noticeable propagation delay. That's the time from when a bit is sent at the sender to when it's received at the receiver. A noticeable propagation delay of 270 milliseconds between a sender or a receiver and a geosynchronous satellite. Well, that wraps up our initial discussion of what's happening at the network edge. Hopefully you've got a better high-level understanding now about access networks and physical media. Next up, we're heading into the network core.
So YouTube is asking us to register every time access of Jimmy. I don't know. So guys, testing time. Quick. Not yet. Remember, for the quiz, I don't care about your quiz. It's a process of learning, right? So that we'll quickly discuss. I only care about your exam. You make it right. That's the part I give the credit. Quiz is just I hope you will. The message is like when you listen to the video, pay attention. If you have questions, we will discuss. Make sense? Right or wrong? It's okay. Make sense?
Okay.
First time doesn't matter. That's always remember I have kids, right? Typically I tell my kids is the first time wrong doesn't matter at all. As long as you learn it. But later on, no second time mistake. Let's get it over with. Okay, quickly. So first one, guys, what did you guys pick? Guys, so for this one, because it's learning process, you guys take notes. Quizzes for this time for you to keep. Sometimes, if the attendance is not good, I will flag it. Okay. Today, because full attendance, the service is everybody's here. Quiz is yours. You can make notes around this. Okay. Okay. So for the first one, what is internet? This is a nuts and the bolts kind of view, right? So remember this that it's not only like one problem. It's a multiple choice. Okay. In that case, what's the correct answer, guys?
1, 2, and 5.
1, 2, and 5.
One, correct, right? Because it's not in the both kind of view. It's basically what's constructed internet, right? Not from service point of view. Then also 2, right?
Yes.
1, 2. Then we talk about networks. Okay. So in this case, 1, 2, 5, everybody is okay, right? Then for the what is the internet from service point of view?
2 and 4.
2
And 4.
Yeah, 4, yeah. 1, 2.
No, I put 2 and 4.
2 and 4, right?
Yes. It's for service. 2 and 4.
And 3.
3, 4, 5.
So guys, when you look at this question, what's the message from this question? What is the practical?
Yeah.
The first one, a person reading a book.
No.
There's no response.
So from this one, what basically my point is, after you done this question, what's the take-home message? When we talk about the protocol, it involves what?
Communication. Communication.
Basic is not from one party, right? At least you need to have two parties, right? Like for example, HTTP, we have what? Request and reply, right? Basic network protocol is more like multiple parties, at least two parties. They are communicating to each other. Makes sense? That's why 1 and 2 doesn't make any sense, right? It's a one-party thing. So in that case, it should be 3, 4, and 5. Make sense? That's one of the big message, right? Then 4 and 5, remember, number could always subject to change when the technology advances. Just to give you a certain sense, okay? For the Ethernet, remember, the access technology in recent years is really changed our life dramatically. Okay, later on we have time, we will still go through, talk some details. For the Ethernet, first thing you need to be what? It's wired, right? Then, what do you guys pick? E, right? It's wired. For the Ethernet, because it's wired, it's relatively fast. Make sense? Okay. Remember, the numbers should subject to change. Okay. Remember, we have twisted pair. Even for the twisted pair, for the back to the Ethernet, they have used to be have category 5. Currently, mostly category 6. So when the generation is going up, the supported transmission rate also could go up. Okay, so this remember just to give you a certain sense, numbers subject to change. Okay, so Ethernet is a wired. Speed is relatively fast, 100 gig in this case. Then the 802.11 Wi-Fi part. This one should be what? Wireless first, right? Then Wi-Fi actually is a wireless local area network. Because it's relatively only within the building, the distance is short. The speed is also relatively okay. But what do you guys pick? F. Okay. And for the cable access network, which is also what? Wired, right? What do you guys pick?
Wired.
For the cable wireless network, I used to live in New Jersey, right? At the East Coast, the cable network used to be really popular. When we watch TV, we have the cable network. Then later on, for the TV network, we added the internet access. In the Texas, when I moved to Texas, the cable never that popular. Okay. In the Texas perspective, for the cable access network should be B, and the DSL, digital subscriber line, which is wired. Come on, mouse doesn't work. This you pick what? G, okay. For DSL, basically it's based on what?
Which one is G? Is it about cable?
Digital DSL. So cable access network, we pick the B as in boy, and the digital subscriber line, we have the G as in green. Got it? Got it?
Okay.
I didn't get it.
Which part you didn't get it?
I didn't get it. Number 3.
Number 3, cable access network, we pick up B as in boy.
Okay. Thank you.
DSL, we pick up the G. Because the reason is what? DSL is based on what network? So you guys, when we you guys too young, right? we used to have a PD network. Used to be cable based.
Yeah.
Then we also have a phone network, right? Now, because you guys too young, is because nobody have the wired phone anymore, right? So the DSL is based on the original phone network. Then we add the extra model. We have the frequency division multiplexing. Then some is for original phone network. Then some used on the wireless part. Make sense? That's DSL. The phone network is based on what kind of physical media? It's twisted. Yeah, it's not as strong as the cable part. That's why supported data rate is not that high. Make sense? Depends on technology wise. Okay, that's why digital is based on, so the rate supported is lower than the cable. Okay, cable is so basic digital subscriber line is what we G. Then the 4G cellular LTE. It is a wireless and guys, for the cellular LTE right now, the 5G should be here, and it doesn't matter. 4G, 5G, 6G, only more diverse. For those kind of wireless network, it's based on the base station, right? So what's the advantage for this wireless network compared to Wi-Fi? If we talk about the wireless part, Wi-Fi is popular, right? Then this one is based on the cellular network. So those two parts, you guys, what's the pro and the cons for each one? For the Wi-Fi part is what? The rate is higher, right? But the supported distance you have, if you walk out of this building, can you still access Wi-Fi here?
No.
The range is much, much smaller. But for the cellular network, it's supported by the base station, right?
Yes.
The rate is lower, but the area is a kilometer. It's not by the meter part. The error is much bigger. Make sense? That's basically how to separate those. Okay? Regarding the 4G, 5G, they have difference, but not that huge. Got it? This is for the different access technology. Okay, last one. Then we will go back to, if you have time, we will go back to link transmission characteristics, right? Which of the following physical layer technology has the highest transmission rate and the lowest bit error rate in practice, guys?
Fiber optic.
Fiber. You guys, who access the internet using the fiber now? You guys, if you live in the dorm, different story. Typically, if you live in the house, the fiber access technology is getting popular. So the time when I got my graduate study at Rutgers, at the time fiber, optic is getting popular. At that time, the device itself is a barrier. In the recent years, device got resolved. That's why the fiber technology is getting popular. Almost all the new houses, new development, we're using the fiber access technology to access the internet. The rate is in the gigabyte per second. Okay? So that's very, you can keep your pace, okay? So let's go back. Quickly review. If you have questions, let me know. Otherwise, we just quickly go through this network edge part, then move on to the network core, right? Guys, when you look at this one, when the author explained in the video, talk about how do you access the internet, talk about the different networks, right? When you access the internet, using a few examples. For example, home network is popular, right? Everybody can access the internet from home, right?
Yes.
Then the enterprise preview is this case, right?
Yes.
Makes sense? Then the upper one is a cellular network. You still use the base station. Makes sense? Of course, for this one, like the data center, that's rather new technology. It's a little bit far away from our everyday life, but we use the data center cloud kind of things all the time. Makes sense?
Yes.
Then, if I ask you now, which part belongs to network edge? Which part belongs to network core? How do you draw those kind of border